Welcome back to the discounting segment. I hope the spreadsheet worked for you. The compounding calculation is the foundation for everything we will be talking about from here on out. This section deals with discounting. You are no doubt familiar with this word. It means a price that is less than the regular price. But in the time value of money world, discounting has a special meaning. It refers to the smaller amount of money I would need to have today if I wanted to invest towards a larger savings goal. I'm showing you an equation here, but I first want to go back and talk about the compounding equation. In both of these equations, there are four terms. In the compounding equation, we knew all the terms on the right: present value, rate, and N per, representing time. Our unknown was FV, or future value. When we talk about discounting, though, we know the future value. That's our savings goal. Our unknown is the discounted amount, which is PV, or present value. So we take the compounding equation and solve for PV by dividing both sides by 1 plus rate to the power of N per. And we get this equation. PV, or present value, equals FV, or the goal amount, divided by 1 plus rate to the power of N per, which is a time element. For us, the number of years. All the terms are the same, but we moved all the known values to the right and the unknown value, PV, to the left to make it easier to solve. That is, easier if we had to do it with paper and pencil. But we have our Excel spreadsheet to do the math. I've pre-filled the spreadsheet with the numbers from our last segment, but this time we know the amount, the goal amount, which is $16,289. Yeah, who in the world has such a specific goal? But let's say it's the price of a small car. Really, I chose this amount so that you can go back to the compounding page to see that all the numbers work out the same. So again, we have a rate of 5%. We're calling it a discount rate to show that we're working backwards, but it's really just the same growth rate. N per is 10 years. And the spreadsheet calculated the amount we need to invest is $10,000. Let's check back on the previous tab to see that it's the same. No differences here. So let's go back to discounting. What I want to show you is what happens when we change the discount rate. So in the second row, I'm going to change 5% to 3%. And what happens to the needed investment? It goes up to $12,120.51. It makes sense. You're earning less, so you have to start out with more. If you look at the equation, you'll see why. If I decrease the rate, which is the denominator, PV has to increase. This is called an inverse relation. The two numbers are like children on a seesaw. When rate goes down, PV goes up, and vice versa. Let's close out this segment by trying one more. In the third row, I'm going to increase the rate from 5% to 8%. And the spreadsheet shows us that the seesaw works. When the rate goes up, the amount I need to invest goes down to $7,544.94. At this point, I'd like you to try a few yourself, using the discounting tab of the spreadsheet you downloaded before. This concludes the discounting segment of this lesson. When you are done working with the spreadsheet, please continue with the How Long segment, where I will discuss the time element.